Today let's talk about vector space over a field. A field can be the set of real numbers or the set of complex numbers. For simplicity, we choose the field to be the set of real numbers. Examples of a vector. Force, velocity, and acceleration are vectors in physical sense, which are presented by arrows, like this, showing their magnitudes and directions. To denote vector A, we can use letter A in bold or using letter A with an arrow above it. In mathematics, however, we define vectors as the elements of a vector space. Operations in a vector space over R. A vector space V has two operations, addition and scalar multiplication. Addition. We define vector x plus vector y as a unique vector in V. That means for all vector x and vector y in vector space V, there exists a unique x plus y belonging to V. The exclamation mark here stands for unique. Scalar multiplication. We define the vector ax, meaning the scalar a multiplied to vector x as a unique vector in vector space V. That means for all real number a, there exists a unique ax belonging to V, and the following 8 conditions hold. Condition 1. For all x, y in V, x plus y equals y plus x. That's commutativity of addition. Condition 2. For all x, y, z in V, bracket x plus y plus z equals x plus bracket y plus z. That's associativity of addition. Condition 3. There exists a zero in V, which we call it a zero vector, such that x plus 0 vector is equal to x itself for all x in V. Condition 4. For all x in V, there exists an y in V such that x plus y is equal to 0 vector. That's the existence of additive inverse. Condition 5. For all vector x in V, 1 multiplied by vector x is equal to vector x itself. For all real numbers a, b, and for all vector x in vector space V, we have bracket a, b, vector x equals a bracket b vector x. Condition 7. For all real number a and for all vector x, y in V, we have a bracket x plus y is equal to ax plus ay. Condition 8. For all real number a, b, and all vector x in V, we have bracket a plus b vector x is equal to ax plus bx. Condition 7 and condition 8 are called distributivity. Cancellation law for vector addition. If x, y, z are vectors in a vector space V such that x plus z is equal to y plus z, then x is equal to y. Proof. There exists V in vector space V such that z plus v is 0 vector by condition 4. So vector x equals x plus 0, or here should be a 0 vector, I made a typo here, equals x plus bracket z plus v equals bracket x plus z plus v by associativity equals bracket y plus z plus v equals y plus bracket z plus v by associativity equals y plus 0 vector plus equals vector y. Here should be a 0 vector. I made a typo here. Theorem. 0 vector is unique. Proof. Suppose there is another 0 vector denoted by 0 prime. Then 0 is equal to 0 plus 0 prime equals 0 prime plus 0 by commutativity of addition. And that is equal to 0 prime. So we know that these two zero vectors are the same. Theorem: additive inverse is unique. Proof: let vector u belongs to V. Suppose V and V prime are both additive inverse of vector u. Then u plus V is zero vector and u plus V prime is zero vector. Then we have u plus V is equal to u plus V prime. By commutativity, we have V plus u is equal to V prime plus u. By cancellation law, V equals V prime. So we know that the additive inverse of a vector is unique. Let's talk about two theorems related to zero vector. Theorem 1. The scalar 0 times vector x is a zero vector for all vector x in V. Proof: by condition 8, 3, and 1, 0x plus 0x equals bracket 0 plus 0x by the distributivity equals 0 vector x equals 0 vector x plus 0 vector equals 0 vector plus 0 times vector x by commutativity. By cancellation law, we have 0 vector x equals 0 vector. Theorem 2. For all real number a times 0 vector is a 0 vector. Proof: a0 equals a bracket 0 plus 0 equals a0 plus a0 by condition 3 and 7. a0 equals a0 plus 0 equals 0 plus a0 by condition 3 and condition 1. So now we have these two equations, and we have a0 plus a0 is equal to 0 plus a0 here. So by cancellation law, we have a0 is equal to 0 vector. This is the end of the video. If you find my video interesting, please consider subscribing to my channel, liking the video, and commenting down below. Thank you. See you in the next video.